Okay, so we have a circuit, we have a large piece of strip board to chop some off, and we have a bunch of components courtesy of Mr. Farnell. So shall we get the soldering iron out and see if we can build something? Okay, and welcome back to Triplicate. In the last video on this battery charger discharger tester, we designed the circuit for it. In this video we're going to put it together and get it working. So without further ado, let's crack on. Okay, started soldering some bits on here, and I'll spare you the entertainment of me soldering, because it does take a long time. That's probably, I don't know, 2 or 3 hours work just to do that. Started off, thought I'd mount the heatsink across the end of the circuit board out of the way, and then sort of started putting it together and realised that the transistor pins would all be lying on a strip, so I'd mount it that way instead. And these were actually pins sticking down out of the heatsink, which I think you're supposed to solder on, which I suppose is alright if you're wave soldering or something, but with a soldering iron you're never ever going to get them hot. That's the other ends into a big heatsink. So I managed to tap a few threads of M3 on each of them and put a nylon nut on, so that's near enough. And then I decided I actually need the circuit planned out rather than just sticking components down and hoping somehow they line up and it all works out sensibly. So that's what I did there, and that's as far as I got with that. And then I decided no, that's alright, I was going to mount the FTDI USB serial board on the corner there. So I've got to go back and change my picture and move a few components, but I think it'll go on alright. So I shall do that, and we'll have an update when I've got a bit further on. Okay, it's all wired up and checked ish. We're going to try first and check out the current measurement controller system. So all I've got now is the power supply connected to the meter on milliamps, and we're going to gradually increase the current and check nothing horrible happens. And the current should be, don't know, 1/10 of a milliamp. It's only through the bias resistors for the gate. So we're increasing the current. So that's 12 volts and we're getting nothing, right. Connection check time, I think. For now. So that's clipped onto something I'm a bit more sure of. Milliamps. Positive. The negative is connected up. Try again. Microamps. No microamps. Okay. I'll have a look into that. Okay, wire off on the power supply. Always a good one. So try again. Bring the voltage up. Nothing. Wire's fallen off that. Which wire should that be? that wire. Oh, it's doing something. 200 and 300 microamps. Yeah, I'll take that. I will take that. Okay, so shall we test the gate circuit now? So, a little more fiddling about. Okay, got a little bit of rubbish out of the way. Negative lead of the meter on 0 volts. Positive lead of the meter via that little jumper there on the gate, which is the top end of that capacitor. So if I wind the voltage up, the voltage I should get should depend on the preset, and with no input this line up with the thingy should take us to 0, from 0, yeah, up to 6 odd volts. That's lots of turns. Okay, 6.34 volts. That's the Zener kicking in. So I am happy with that. So I am going to drop that to 3.6 volts. Remember, anti-clockwise increases that gate bias. And I am going to fiddle around so I can put 5 volts into the input and test that works. Okay, ever more spaghetti. So now we have this, which is a 20 ohm YOM potentiometer, because it's the only low value one I could find, and it's getting quite warm because it's got 5 volts across it. So that's just over a watt is firing. So that is going to the PWM input. Now we're using a DC voltage because it's easier in this case, at this point, just for testing. We know that PWM works, and we'll test it again once we connect it up to the Arduino. The reason I'm testing it with all this jury-rigged wires everywhere is because I don't want to just connect it up to the Arduino and put 12 volts where it shouldn't and blow my Arduino up. So here we have the voltage. So this is at 0 volts, and that's 3.5, which we set on this. So just there we go. Set it to 3.5 dead, shall we? Or thereabouts. So now if I wind this up, the gate voltage, come on, is increasing nicely. And tops out at about 5 volts. We might need a bit more gain on the input. Never mind, we're going to persevere for now with what we've got. So I think it is time to connect a load up and see if we can actually draw some current out of this thing. So, ever more spaghetti, we now have a vintage 22 ohm resistor. connected between the input of the current sense, that's this yellow wire, and 12 volts. And now we have the meter on the output of the current sense. So if I ignore the dog, turn this up, we need to see under there, is there? This is 1 ohm, so 1 volt is an amp. Oh, let's have the current limit turned up on the power supply. So 90 millivolts, that's about nearly 100 milliamps. Oh, that's no good. What's gone wrong here? Right, so if I increase this gradually, we're on 100 millivolts. Okay, so it works to a point, and then you get to a certain gate voltage and it bombs out. Time for me to have a look around and see what's happening. Oh, comes back up again. I suspect this pot is a bit cruddy. It may well be 40 years old. No idea where I got it from. I will clean it up and we'll try again. You can see that deoxit, that's what I use for cleaning up cruddy contacts. Sprayed a load on the back of this ancient pot and it seems to have worked. So now we can see the millivolts going up. My phone going off. Nice too. About there, that's about half an amp. Nearly at the top. And I suppose you can't see it with the analog current meter on the power supply, we can see going up nicely up and down. So I think we have a success there. Okay, first up, shall we see if the relay is working? So, yep, let's just get 1 or 2 wires out of the way. Let's turn the power supply on over here. Right, that pink wire is the drive to the relay, which should drive from 5 volts from the Arduino, and that end of that pot is 5 volts, so if we touch that to there, yep, we get a click. Okay, so the relay is working, so should we, I don't know, connect some batteries up or something and see what and see if we can get the thing working properly. Okay, so I've soldered it together to make the spaghetti a little more reliable. So what we've got here is 4 batteries. I haven't plugged any batteries in yet. In a battery holder with a 22 ohm resistor in series for safety, so we're not going to short across the batteries if something goes wrong. And I have this scope probe on the positive end of the batteries with resistor, and this on the negative end, so we can use the scope to measure the voltage across the batteries. We have here the bot providing the charging PWM in inverted commas. This switch will go to there. It's the charge discharge, this wire, charge discharge switch. And the meter is measuring the current sense. So none of it's powered up, and as you can see there are no batteries in, so I shall find some batteries in, start the scope up, power it all up, and we'll see if anything is going to happen. Okay, after much swearing at these dreadful, terrible battery holders I found in a drawer, I've taken to putting 4 batteries in my nominally 12 volt, a 10 battery pack, and these are going in the bin. So we should be ready to go. So here we are. The blue trace is the battery positive and the red trace is the battery negative, and by default it's in discharge mode. So the bottom of the battery is at 0 and the top of the battery is at about 5 volts, which is for fully charged batteries. And we have 0.2 of a millivolt across the centre resistor. You see those? They're out of shot, aren't they? Are they? Anyway, we do. You can see on the meter. So let us start, and that's down at 0, and wind the voltage up. Oh, that doesn't sound good. That is the resistor, the relay going crackers, and it shouldn't be doing anything because this is the drive to it, which is this wire, not connected. Okay, we have a problem. I shall investigate. Alright, it looks like there's a bridge of solder across there. I changed that because I got it wrong and I didn't go back and check with a magnifier that there were no bridges. This is quite a high powered magnifier, which is the one I normally use for doing this job. Give me a swine to find where you... It looks alright. Shall we try that? Shall we try that? That's better. So that's about 12 volts. The batteries are still doing what we think they should be doing. There's a spare piece of wire there, which I shall move if I can get hold of it. 8 milliamps. That's because we haven't set up properly the gate bias, but I'm not worried. So if I turn up the pot, I'll try to. There we go. Okay, we are getting some current. $100 milliamps. 200 milliamps. What I would expect to see is the I'm measuring the voltage across the batteries, not the resistor. This resistor is just to make it easier to see effects and stop everything burning out if there's a nasty short circuit appears. So now if I turn the current up, come on, yeah, we can see the voltage dropping because it's got 22 ohms in series with it. So if I put the voltage back to the current drive back to nothing, grab this and put this to 5 volts. We now see that the top of the batteries are at under 12 volts. If we turn the current up, yeah, we then should see the lower voltage, the battery negative, because the battery positive is now connected to the charging voltage 12 volts, and the battery negative is being pulled down by the current source. Oh, it's not getting hot, and quite a long way because it's got this big resistor in series. And that's 200 milliamps, which is what we're expecting to charge at. Okay, let go of this again. Bang. What's the matter with this thing? There. Yep, pulls the supply down because it's got such a high series resistance, 22 ohms. And it just can't draw very much. It's not a problem. And if I again fire that in, yep, it's charging her up. So what say we take that big resistor out, or so we are going to what was that shorting against? What the hell's happening there? I don't know. Why I wasn't connected to anything. Right, so now on the discharge. Oh. What's going on here? Set it in discharge mode. we can put it up to 230 milliamps. Doesn't drag the voltage down hardly because these have a very low internal resistance. Connect it back up to charge mode. Similarly, we can tell it to charge at 200 milliamps. So I am going to call that a success, call that a hit. So now we need to connect this, all these wires here, to that guy. And I plan to use the shield just for connections, and in case you're wondering why didn't I build all this on here, because it just would have been too much of a pain to try and connect it all up with these pads that don't go anywhere. However, I do plan to put some LEDs on the top here, just so we can see what we're doing if we're not connected to the computer. So I think that is it for this installment of this battery charger tester video. So if you like the channel, please subscribe. If you've got anything to say about this video, please leave a comment. Thumbs up possibly, and for now it's goodbye from Triplicate, home of interesting electronics. Goodbye.